Hello there and welcome to A2 Maths from Specimen Paper 2, and here we're looking at question 2, a small angle approximations question. So given that theta is small, use the small angle approximation for cos theta to show that this thing on the left hand side is equivalent to the thing on the right hand side. Let's just recall from the formula booklet what the small angle approximation for cos is. It's 1 minus theta squared. So let's substitute it into 1 plus 4 cos theta plus 3 cos squared theta. It's going to be 1 plus 4 bracket 1 minus theta squared over 2 over 2 plus 3 lots of 1 minus theta squared over 2 all being squared. Okay, so this is the left hand side, which is equal to 1 plus 4 minus 2 theta squared. So 4.5 will cancel out there. And then for the quadratic one, a little bit more tricky here, 3 minus 3 theta squared, and then it's going to be plus 3 theta to the 4 over 2. Is that right? Yeah, over 4, sorry, because we need to square the 2 as well to make it 4. Now, we haven't got any thetas to the 4 over here, so what we're going to say here is that this thing will tend towards infinity, so it will tend towards 0. Theta to the 4 will be very small, so will be very, very small. As you power a very small value, it gets even more smaller, so therefore theta to the 4 will be very, very small, so therefore it would just effectively just be 0. So let's now simplify what we've got here. 1 plus 4 plus 3, that's 8, and minus 2 theta squared minus 3 theta squared, that's minus 5 theta squared. So there we are, that's our answer for this question here, part A in the bag. Let's now move on to question B. So Adele uses theta equals 5 degrees to test the approximation in part A. Adele's working is shown below. B, part I is identify the mistake made by Adele in her working. Okay, so she used a calculator to start with, 5 in degrees mode, worked out what that needs to be, then substituted in 5 into this expression here and got minus 117. So it doesn't look like these two numbers here match up at all. Adele's mistake was that the angle needs to be in radians mode. Okay, so having your angle in degrees mode is not allowed. Your angle must be in radians mode. So that was her mistake. So B parts II show that 8 minus 5 theta squared can be used as a good approximation to that expression there for an angle size of 5 degrees. Well, the first thing we'll need to do then is to convert 5 degrees into radians mode. So 5 degrees in radians. Now remember, if 180 degrees is pi radians, and if we want 5 of these, so 5 degrees, then what is 180 divided by 5? That's 36. So if we now divide both sides by 36, we're going to get 5 degrees equals pi by 36 radians. So that's the first really important step to calculating this approximation here. 5 degrees needs to be converted into pi by 36 radians. Now we can use this expression here, so plugging in pi by 36, 8 minus 5 pi by 36 squared. So let's now substitute that in. So we'll put pi by 36, square the answer, and then do 8 minus 5 answer, and we get 7.919. So that's to 4 decimal places. And what did Adele have before? Adele had 7.962, which is remarkably similar to what we've got here. That's a pretty good approximation there. So there we are. That's the answer to this question then. We've approximated 5 degrees as 7.9619 to 4 degrees, 4 decimal places. So there we are, that's the answer to question number 2 then. That's 5 marks in total. Let's move on to question 3.